My name is Victor Odigomoye, and in the previous classes before now, remember we are still looking at circle and its properties. Circle and its properties, and we have done a lot of work already in circle and its properties. We have looked at chord, theorems, and its application in solving some problems. Okay, remember we started with sectors of a circle, and then we have done some calculations like perimeter of a sector, length of an arc, and we have continued to solve more and more problems. I'm saying this because if you have not checked out those classes, it's necessary to check out those classes because it's going to help you to understand what we are doing in the current time. Okay, so without taking our time, in our today's class, we are going to be looking at another problem altogether. If you look at this question here, this question says an isosceles triangle LMN has its vertices on a circle. Okay, now if LM is 13 cm and MN is 13 cm and LN is 10 cm, it says calculate the height of the triangle. Calculate the height of the triangle and calculate the radius of the triangle. So quickly, what I normally do, I try to make the solving of any problem I'm going to do here to be so realistic, so that you can be able to see the stages that we go through in order to be able to solve any problem that we are solving. So let's do it together. Let's see how we can be able to handle a problem like this. Okay, so if I have this type of problem, the first thing I'll do is to put up the diagram. Okay, I'll put up the diagram. So assuming I have let me check how this thing is going to be. So it is going to be too big, too big, too big, too big. Let's reduce it a little bit and shift it forward. Okay, so I will have this triangle, this circle, that we definitely have a triangle inside it. Okay, okay, okay. Let me mark that. Okay. Now we are being told about an isosceles triangle. Now you realize that an isosceles triangle has two sides equal. I'm sure you will know that an isosceles triangle has two sides equal, two sides equal, two sides equal. So if I draw this triangle, they say that the labeling is L M N. Okay. Of course, according to the information, they say LM 13 cm, this side too 13 cm, and here 10 cm. 10 cm. Okay. Now they want us to calculate the height of this triangle. Of course, the height they are talking about should be something like this. Something like this. I will ensure that this line will pass through the center of the circle because it will help us to make some statements within here. Okay, I will ensure that this line passes through the center of this circle because it will help us to make some statements here. Now, when I was discussing about chord properties in the previous classes, I was telling us that a line drawn from the center of the circle, a line drawn from the center of the circle, which touches a chord, is perpendicular to that chord, meaning, and it forms angle 90 degrees with that chord, and it bisects that chord, meaning it divides that chord into two equal parts. So that theorem, we have looked at it, and we have even used it in doing some calculations, of which this is one of it. And I think the next one I'm going to also do, you're also going to see me use that theorem as well. So if this line is coming from this center of this circle, touching this chord, obviously this chord LN is bisected. So permit me to remove this and put 5 cm here and 5 cm here. I think that is very, very okay. What next? Now the question says find the height of the triangle. Of course, I can label here H. Wow, the height of the triangle. So I am going to make some extractions from this list. So what I'm going to do now is I'm going to extract one part of the triangle. Okay, I'm going to bring out one part of the triangle. So this is what I will have. This is the H, the height of the triangle. This is 18 cm. This is M, and this is N. And let me call somewhere here T, sort of. Okay. So this is 5 cm here. Now, all right. Now, for me to calculate H, you know where the concept I am going to borrow. Okay. It's called Pythagoras theorem. That is what we are going to make use of to be able to calculate H. I'm sure you know why. Because this is a right angled triangle. You apply Pythagoras theorem in solving sides of a triangle. Of course, that triangle must be right angled triangle before you can do that. Okay, so here we go. The opposite square, that's what Pythagoras theorem says, that mt squared plus tn squared will be the hypotenuse squared, which is mn squared. Alright, so here we have h squared plus 5 squared is equals to 13 squared. So this is h squared equals 169 minus 25. So 5 squared is 25, 13 squared is 169. So if we have here this subtraction, remove 5 from 9, that will be 4. Remove 2 from 6, that will be 4. So I have h squared equals to 144. So h is equals to square root of 144. So h is equal to 12 cm. So the height of the triangle is 12 cm, 12 cm, 12 cm. Okay, it's 12 cm. All right. So what x do we have? The question says, find the radius, calculate the radius of the circle. There is something I'm going to do now. There is not the only way. It's not the only way, because if there is a theorem, you are going to follow me today. Next classes I'm going to have where I'll be discussing circle theorems. The first theorem there we are going to look at, it says the angle which a chord subtends at the center of the circle is twice the angle which it subtends at any other part of the circumference of the circle. So that theorem is important. So we are going to deploy that theorem. We're going to deploy it in finding this. I said that is not the only way, because if this is the center of that circle and I bring it here and I make a marking this way, you can be seeing something there. Look at it. If I make a marking, am I going to be straight? Let's see. Okay. And okay, okay, okay. So so if this angle here is theta by that theorem, this one here at the center will be 2 times theta. Angle at the center is 2 times angle at the circumference. Okay, so I'm going to use this theorem. I'm going to apply it now in solving this problem. We're going to see it's quite a little bit simple. It's simple, yeah, it's simple. But the question now is, how do I calculate this? How do I calculate that angle there? I am going to take a walk, but you just follow me a little bit. Do you remember sine and cosine rule and its applications? Now, we use cosine rule when 3 sides of a triangle is given and none of the angles is available. So, I am going to be using, without taking our time, I'm going to be using, now I have a triangle. Look at this. I have this triangle now. I have this triangle. Here is 13. Here is 13. CM. CM. Here is theta. The angle I'm looking for, called M. Okay. This is N. And this is N. And here is 10. 10 cm. Alright. And I'm looking for theta. And if I get theta, I'll use it and enter inside that place. Don't worry. Don't worry. We are going to get it. We are going to get it. Just take it step by step. Alright. So, I am going to calculate this theta. I will say solving for theta using cosine rule. That cosine rule says cos theta or cos m is equals to L squared plus N squared minus M squared all over 2Ln. I'm sure we follow that. That is to say, by implication, let me come over here. I'm sure this one, look at it. I'm going to be discussing this cosine rule later, but I'm trusting God that this side L is this, okay, N is this, and then M, the side that's facing the capital angle M, okay. So that is that. But trust me, if you have any question on this, please make your comment in the comment section so that I can be able to follow you up. Any confusion at all you have on this, please put up a comment there. I'll follow you up. Okay. All right. So where are we? Substitution. We substitute. So we will have cos m equals 2. So we have 13 squared plus 13 squared minus 10 squared all over 2 times 13 times 13. So this will be equals to 13, 169 plus 169 minus 100 all over 2 times 13 times 13, I think will be, yeah, it's squared 169, then 169 times 2. I have a figure here so that I don't take our time. That's 338. 338. Okay, now I have this plus this minus 100 to be 238. So I have equals to 238 over 338. Okay, so that's cos m. Okay, so m, if you take this to decimal, we are going to have 0.704. So I have cos m equals to 0.70412. Okay, so m is equals to cos inverse of 0.70412. Okay, so m is equals to If I take the cos inverse of this, I will have M, the angle M, to be 45.24, 45.24 degrees, 45.24 degrees. Now, if this is the angle here, if this is the angle here, now, times 2 of it will be at the center. Don't worry, we are going somewhere. Times 2 of it will be at the center. So the one that will be at the center will now be, this now, let me relabel it as L, M, N. This angle is this. And then the one at this is at the circumference. Now the one at the center, at the center, will not be L, O, N. Let me call that center O. Okay, this angle will now be 2 times, okay, 2 times 45.24, and that will give us 90.5, 90.5 degrees. So this is the angle at the center. What am I doing all these things to use it to? The target is, remember, we want to calculate this radius. That's what we want to calculate, that radius. Now, permit me to extract a triangle of this nature now. A triangle that has something like this. A triangle. Now the center is 90.5. This is radius, and this is a chord LN. LN being 10 cm. Okay. Now I'm going to use the formula for calculating the length of the chord, which says 2r sine theta over 2. Okay, so ln is equals to 2r sine theta over 2. So this is 10. Okay, 10 equals to 2r, because this will not help us to subject r. It will help us to subject r. I'm sure that is very clear to us. Then sine 90.5 over 2. So I want to divide both sides by 2 here. That is, this side by 2, this side by 2. So here will be 5 equals to, these 2 will disappear on this side, and I have r sine. Half of this is 45.24. We have seen it before. So if I divide both sides, again, both sides by sine 45.24. So you have 5 over sine 45.24 equals to r sine 45.24 over sine 45.24. So you see that r will stand here equals to this. So let me say r is equals to sine 45. I have a figure here already. Sine 45 point is just the opposite of what we had, the inverse or the reverse of what we had before, when we calculated, I think this. Yeah. So that will give us, the reverse is 6. So sine of this is this, 0.70412. Okay. So 5 over this. So radius is equals to, so if you divide 5 by this, in the calculation I have done already, to be faster, it will be 7.04 cm. Oh my God, I think it helped. I trust God it helped us. It helped you to understand this. I trust God you understood everything that I did here. Starting from the procedure, calculating the height of the triangle. Then this uh, cosine rule I adopted is my choice. I know you, someone, my colleagues out there, you might choose to, or you as a student might choose to utilize this 5 cm here, this radius here, and the angle here. Of course, the angle here will be half of that 90.5. Here will be 45.2, and then this side will also be 45, because by this, you know, coming from the center of the circle means it divided the angle here into two. Okay, so that is that. You can choose to use that and extract a right angle triangle here, and then use SOHCAHTOA, what we call SOHCAHTOA. That is, if the angle here is available and I'm looking for this, I would say opposite of the ratio of opposite side and hypotenuse side is the sine of that angle. So you can still use that method to find that radius. All right, I trust God that this explanation is very, very okay. So please like our video, and if you subscribe to this channel, you will see over hundreds of classes we've had already. They are there. You will be able to access them. You'll be able to access them. Please share to your friends out there, and by so doing, you are also helping them to achieve their goals and succeed in their academics. Thank you so much for being there.